Okay, good morning again and Happy New Year. Welcome to EECS2011 Session X, right? And I'm your instructor, Jackie, and my plan today, I would like to go over the syllabus to make sure everything is clear to you. But please notice that the syllabus might still be subject to changes until 2 weeks later. But hopefully today will be pretty much the finalized version. I'll go over the syllabus, and then I want to give you some introduction to why we need this course. It's quite a foundational one, given that you have already finished 1022, or 1021, and also 2030. Now is the time to have more application to see how data structures can be manipulated. And then, if we have time, I'll try to do a little bit of review on recursion, which will be used intensively this class. I'll talk to you about my plan about covering recursion. I thought that might be the best plan for you. Anyway, we'll talk about it. If we cannot finish recursion, we'll do that on Wednesday. Okay. Myself, feel free to call me Jackie. I'm very informal, but if you really want to call me Professor Jackie, Professor Wang, that's fine, okay? And anytime you need advice on the course, ask for help as early as you can. Please don't try to only ask my help after maybe you have performed poorly on the test. Sometimes it may not be so useful to get my feedback around them. Try to get to me early. I'll try to make myself as accessible as possible. And so there will be a bonus opportunity for you guys, actually two. Well, actually three. One would be we're going to do some midterm course evaluation, informal, anonymous. It will be on the E-class for you guys to give me some feedback to see if there's anything I can adjust, either for this course or maybe for later iteration. So this is my second time teaching this course. Another bonus opportunity will be the final course evaluation that's formal. I'll get to you. I'll reach out to you. Another very substantial bonus opportunity will be to take attendance in the class. I'll also talk about it. It's documented in the syllabus quite clearly as well. We'll get there. And throughout the semester, suggest any way you like if I can make your learning easier. Okay. Right, so in case you're not enrolled in the course just yet, so you are supposed to reach out to me as soon as you can, and you want to give me your name, student number, and passport your ID. The login name, don't give me the password. I don't need that, okay? And then I'm gonna log you in. I'm gonna enroll you in the E-class for the course, so you wouldn't miss out any important information. Okay, and then, sorry, my computer freezes slightly. And before you get enrolled, you definitely want to still keep up with the class study materials. And then you still want to complete the assignments and also tests. No extension, all right? So please, make sure you keep up with the course right from the beginning. And about the mask policy, I wouldn't say much. The university kind of recommends but not require. So I'll leave it completely to you guys. But do consider wearing a mask when you feel the need. Minimize talking if you can. You guys are very nice so far. And try not to consume the full drink. Okay, anyway. But in my office hour, I'm going to offer that in person and also Zoom. If you come to my office hour, I'll really grateful if you can wear a mask to come to me. Okay, class protocol. And please try not to use your mobile phone or talking. I'll really appreciate it. And also the slides, which I'm going to show to you, but lecture by lecture, they will be quite self-contained. So what I will try to avoid is to really simply read off the slides. I'll try to have more interaction and more example walkthrough together with you. I think that's the best way to learn about data structure. And core concept and example, and also your engagement is important. Since you are here in person, why not ask questions anytime you like? And writing email to me, as I said, I'm very informal. You don't need to keep the email so formal. But as long as it's not rude, I'll be very happy to answer you right away. I'll try to answer to you as soon as I get back to my computer. Okay? And you can read over some example, being rude or being nice. Okay, course information. There will be two sites you want to pay attention to on a regular basis. The first one, the internet seems to be working, so I can show you quickly. The first one is an E-class site. If you guys already received an announcement from me yesterday, 2 announcements, then you're pretty much set up. So let me go there, and I may have to log in. That's really annoying. If you can bear with me just for 20 seconds. By the way, that's something you will need. I'll explain that for your written test. Oh, of course, no internet connection. There we go. Sorry. This one is not planned. There we go. Approve. Sorry for the interruption. There we go. So that's the E-class site for section X. At the moment, not too much information there. Oh, by the way, it's hidden. It's instructor view, not a student view. So you wouldn't see anything here. Later on, I'm going to add several sections here. For example, I'm going to add assignments. All the assignment instruction will be put here. And also, there will be some example written test or example programming test, which will also make available on the E-class. Right? That's something I will reach out to you. Every time I think something you should really pay attention to, I'll send an announcement to you on E-class. And in case occasionally you might miss some email from E-class, I would suggest always go to the course announcement section. Just make sure you stay up to, on top of the course. Okay, so that's about the E-class page. Announcement, assignments, written test. So I'm going to talk more about the written test as we get there. But written test is going to be multiple choice based mainly. There might be some written part, but I'll give you more information later. But the written test is going to be taken in person. There will be a venue which I'm going to confirm, and then you'll go there and then attend the test. And then you got to log in into the E-class, and you might be asked to actually verify yourself using the dual mobile, like what I just did. So please make sure you get ready for that. That's the only minimum I ask for you before the test. Otherwise, you'll be wasting time during the test. And you want to check your emails regularly, okay? Any questions so far? Okay? Okay. And the second site you would like to pay attention to will be this one here. So that's the site. If I click, that will be the link, but very easy to find. You just go to my homepage. You go to www.eecs.yorku.ca/tell.jackie. Okay, you can easily Google me. You can also find it. And then, so that's the site over here. It's public domain, so you don't need any PPY passport. Okay. The idea would be I will post the lecture material every time after the class. I'll try to make it available on the same day, but if not, I'll definitely try the next day. Okay. There will be some recording for today, and also will be some notes which I write on my iPad, and there will be the slides. So for the slides, sometimes we may not be able to cover the whole PDF in a single lecture, in which case you may not want to print it out just yet, because I might still do some minor edits. Okay. And these are the links to several documents which we're going to go over. Syllabus, slides, which I'm presenting now on the administrative issue, weekly schedule, and semester's calendar. Right? We'll go over each one of them, one by one. And if you really want to join my office hour by Zoom, you can definitely do that. So you can click on this link. If you want to come to my office in person, so that's my office in Lausanne building, second floor. And for those of you who may actually want to use a GitHub to back up your programming assignments, you can feel free to do so. I will include that instruction in your assignment 1 as well. But if you want to, you can feel free to check it out if you haven't done so. And there will be some background study because we assume competent OOP skills in this course. And that's why we actually got programming assignments, and also we got programming tests, which I will explain. But if you really want to catch up with some topic about OOP, you can refer to 2030, the topics. So I include 2 links for you. You can just go there and check. All right? If you got any trouble understanding the basics, reach out to me as early as you can. Because in this course, we definitely assume something very fundamental, which you cannot afford to miss them when you take this course. Okay. Let me go back. And course syllabus, we'll talk about course syllabus page by page in just one moment. Oh, right now, actually. Before I go over the course syllabus, do you guys have any questions, please? Anything you want me to clarify right away? We okay? Okay. Let's now go over the course syllabus. Oh, over here. Okay. Sorry, let me just make sure I keep track of the time. Okay, so the course syllabus will be here. Oh, where can you find it? In case you have access to internet right now, you can definitely download it if you want to. You can see under the lecture site, go here, course syllabus, over here. Okay, click on that, you will see the PDF. Okay, let's now go over that. Okay, course policy. One thing which I experimented since last semester, I kind of like it, so I'm going to continue with it. So for your programming assignments, there will be 4 of them. The idea goes as follows. Number 1, collaboration and getting help about solution before the submission deadline is 100% allowed, positive. Number 2, by the submission deadline, as long as you submit your best attempt, meaning that if you submit something, then you get full marks for the assignment, no matter what. These are the 2 principles that's documented here. And how do we check if you really have done your assignment properly and also make sure you clarify any doubts that's associated with the assignments? We have programming tests to test you on that. So please make sure for your programming assignment, it's really meant to be a learning opportunity. I don't want to give you any stress about losing your mark by trying the assignments. But on the other hand, your responsibility will be to get all the help you can to actually complete the assignment. Talk to your classmate, that's okay. Go to the TA, come to my office hour. Even if you just ask for some hints on the solution, we will be happy to help you on that. Okay? That's the idea about this policy over here. Okay, I'm not going to read it, but you can read it. Make sure you're familiar with the policy. That's about the assignments. But for your scheduled tests, there will be 4 of them. 2 written tests on E-class and 2 programming tests, also in person. And of course, no collaboration will be allowed. There will be some invigilation by the TA and myself. Okay, so please make sure you actually follow along the lecture materials for the written test, and also you complete the programming assignments on the for the programming test. Okay, and for your assignments, I'll try to see if I can schedule some extra optional, either Zoom or in-person sessions, so I can go over the solution with you, just to make sure you're fine. I'll get to you, maybe to see which time that might work the best for every one of you. We'll talk about it. And, okay, yeah, the deadline, okay, even though you can get full marks for your assignments very easily just by submitting your best attempt, but you got to make sure you respect the deadline. If I say, for example, it's 2 p.m. on Monday, you got to make sure you submit by then. If you miss the deadline, you don't get the marks, all right? Guys, any questions so far about the policy? Please. Very good question. The question was about where the written tests and programming tests are going to take place. Tentatively and most likely, they will take place, number 1, during the class time on Wednesday from 10 to 11, tentatively. And it's not going to take place here. It's going to take place in a lab, which I already reserved from the EECS building. You can pick a note. It's going to be in the Williams Small Center, WSC. Okay, I'll confirm with you guys about the exact venue and time as we go. All right? Yes, please. Yeah. Very good question. So for the programming test, where do you actually develop your code? Absolutely IDE, Eclipse, to be more precise. So guys, maybe that's how you train yourself, maybe by writing some code on the paper. You know, to be honest with you, for the final exam, you will need to write some code on the paper. It's going to be a very substantial, cumulative, in-person paper exam. So you'll definitely be expected to write some code on the paper. Keep that practice for yourself. But for the actual programming test, you will have to, I'll just briefly mention, but I'll definitely give you more preparation. Number 1, you will be given some JUnit test cases to begin with, which will tell you exactly how the method should be declared. Number 2, the JUnit test will tell you certain example scenarios for which your method should really pass. And then your job is to create a method from scratch and make sure you pass the test cases. Okay? More information to come. All right, any question, please don't be shy to interrupt in case I don't see you. Okay, instructor, that's fine. Okay, so here I think the only thing you want to read, one thing just to mention. The office hour is going to be 3:30 to 4:30 p.m. Tuesday, Wednesday, and Thursday, starting from this week. So if you want to talk to me tomorrow, come to my office. Okay, you can either come to my campus office or click on the Zoom link. But please just understand that I will just give priority to those who actually show up. But in case nobody is showing up in my office, but you call via Zoom, I'll definitely answer your call. So if I don't answer, please just wait. I'll definitely get to you. OK, that's about the office hour. And for the lecture, nothing surprising. Oh, since it's winter time, it seems like we're getting a warm winter, but who knows? We might have some major snowstorm coming. In case the weather wouldn't allow us to really come to the class, I'll let you know well in advance, in which case we might just do a Zoom lecture, or I just release some good quality, hopefully, lecture video to you for you to study, right? That's just in case. Unless I send you an announcement maybe the evening before the class, otherwise you assume everybody should be here. Well, at least you should be here. Okay. E-class site I talk about, and for the study materials, there will be no required textbook for this course, but I do have some suggestions over here. You can definitely take a look. Okay. Many examples which I used were adapted from this particular textbook. If you want to read it, good for you. Okay, it's completely up to you. Otherwise, the single source you have to study very carefully is whatever notes, slides, recording, tutorial, or extra exercises I post on this site. That's basically what you're going to study to really do well in this course. Yes, please. I believe so. Yeah, the question was, do the optional textbook have any problem set? I believe so. I think it's a very standard. I think for every standard textbook, it definitely, I think it does, either at the end of the chapter or in each section. Yeah, check it out. Yes. All right, and for those of you who may just want to brush up on certain topics for OOP, you can definitely refer to 2030. And you can either refer to my 2030 back in 421. That's more like an in-person. Oh, yeah, sorry, I'm just getting a little bit confused. Either you can go for the 421. That was remote delivery. I think that the quality of the videos there are quite good. You can definitely refer to them. They're more complete. On the other hand, you can also refer to my in-person delivery for 2030, right? For 422. Either way, if you want to catch up already. And what kind of help resources can you get? We don't really have any scheduled lab for this course, unlike your 2030. So you can definitely make use of my office hour. If you want to, if the time doesn't really work for you, or you need some extra attention from me, ask for appointments. I'll try my best. And also the TA office hour. This semester, I want to do something a little bit new, a little bit like online. So rather than having a very fixed hour on campus for the TA to be there and you go there to ask questions, I'm going to work like this. I'm going to give you the email of 1 or 2 TAs. Whenever you have questions, send an email to them and then try to intersect a time where they can set up some Zoom meeting with you. I think that might be the best. Of course, the TA is going to keep track of how demanding this service might be, in which case we'll see how we can adapt. Anyway, I'll give you more information on that. For now, we are fine. I'll try to give you the email for of the TA maybe next week. I think starting from next week, you might have more questions. But for this week, we are fine. All right, prerequisite, I'm pretty sure you have satisfied that. And for course description, basically, we're going to talk about fundamental data structure. That's exactly what the title is. Specifically, we're going, let me give you a little bit heads up over here. There are 2 kinds of data structure we're going to talk about in this course. The one is more, category number 1 is more like a basic building block. I'm pretty sure you have played maybe Lego before, the individual blocks, you know, for you to build something very exciting in Lego. These are like building blocks. And there are 2 building blocks, 2 kinds of building blocks. One will be just array, which I'm pretty sure you have done a lot in the previous courses, but I'll try to give you a little bit more new angle to it. And another one, maybe new to most of you, is called linked list. Specifically, we're going to cover singly linked list versus doubly linked list. And in order to understand and do well on the linked list problem, you have to be very good in tracing program, especially aliasing. Okay, aliasing is definitely some concept you learned from 2030. In case you're having some trouble with it, review it, and then we'll get to me. All right, aliasing. And the second kind of data structure will be the more the one that will be built on top of either linked list or arrays. Just give you some example. Stacks, queues, trees, and also graphs. Right? So these are just an example. In this course, we may not be able to cover graphs. That will be covered in your 3101, maybe in your third year. Well, yes. But for these three, we'll definitely cover in detail, specifically the trees. There will be lots to talk about in the trees. But we'll most likely start talking about the trees after the reading week. But we'll try to prepare you for that. Okay, for the course learning outcome, for now, we don't need to worry, but I'll make sure you will actually be taught properly and assessed properly in order to achieve the learning outcomes. Just follow my pace, you will be fine. Okay, grading scheme. Okay. One thing I already mentioned before, for your assignments, 2.5% each, 10%. As long as you tried your best, submit your best attempt by the submission deadline, 10% is guaranteed. All right, it's set in the stone. Okay. What about others? There will be 2 programming tests over here on the IDE, Eclipse specifically. Oh, by the way, for this course, we're going to use the Eclipse IDE. That'll be the standard, because when you submit your assignments or when you submit your programming test, the grading script, the grading program assumes you use Eclipse. So the structure has to be consistent. If you really want to use IntelliJ, for example, feel free to use it just for your own exercise. But for submission, for anything official for the course, please, Eclipse. Okay? In case you really want to catch up with some basics about Eclipse, for example, how to use a debugger, how to use the breakpoint, reach out to me. I'll give you some nice tutorial videos to help you with. But for now, I assume everybody's okay. And 10% each is going to be 20%. Okay? The next one will be, there will be 2 written tests over here, also 10% each, so 20% in total. And for your written test, I'll definitely give you some example later. Number 1 is going to take place in E-class, but it's going to be in person, in some lab, most likely WSC, Williams Small Center. And mostly it will be multiple choice question. There might be some written question for which maybe I'll let you know, maybe in advance of the test. For now, you can assume most of the question will be multiple choice, most of them. Okay? And what really remains will be the final exam. It's going to be cumulative, covering everything from day 1. And it's going to be 50%. Okay? And I'm a firm believer about having an exam that's really cumulative and also substantial. I know you may not like it. I'm sorry. That's just my judgment. That would be the best for your learning. But that's okay anyway. So I'll try to explain my view about having such a substantial and cumulative exam and try to adapt to it if you decide to stay in my section. So it's going to cover all the study materials. The way I see it, it would be a very good opportunity for you to synthesize all the topics together. Remember I talked about arrays and linked lists, for example. We kind of cover them in isolation in the lecture, one after the other. But in the exam, you will be able to have a chance to study them together, and you'll be asked questions maybe to compare these two. That would be something I really want you to have by the end of the course. Okay? Synthesize, that's really the term. And let's see. Yeah, what will be the best preparation for the exam? You want to really review the course material, hopefully not on a monthly basis or even on a semester basis, right? Try not to only look at the material before the test or briefly before the test. Try to maybe look at them maybe every week. That will save you a lot of time at the end, okay? And of course, having a 50%, it's a pros and cons. The pro is if you didn't do so well before the exam, 50% can save you a lot. Of course, symmetrically. If you did pretty well before the exam, but if you didn't do so well on the exam, of course, you can still wouldn't have the expected result you have. Right, it's both ways. Yeah. Try your best. Guys, any questions so far about grading scheme? Yes? It's a very good question. Basically, let me boil down a little bit more directly. How difficult are the tests, right? I can tell you that for both of them, programming test, of course, you have to make sure you master the assignments. And for the written tests over here, mainly about all the lecture materials, or I quote, the theories that we talk about in the class. I would say, to your question, it will be yes and no, right? Let's say if you really follow along all the materials in the class very well, does it really guarantee you will get a very good result? I would say very likely, right? Of course, if you didn't follow through the lecture material, there's no way you can do well. But it's really hard to say because in every test, I try to give you something that's very basic, maybe about 30%, maybe around that range. And then the remaining 70% will be something very similar, maybe to what you saw in the lecture. But you definitely have to know how to be creative in maybe solving new problems. It wouldn't be completely off what we actually teach in the lecture or in the assignments, but you will definitely be challenged, for sure. If I simply tell you that if you follow through everything, you will just get an A, I'll be lying to you. I don't want to, right? Let me be very honest to you. And you may have seen maybe some reviews on Reddit somewhere. Maybe people complain about my test being very hard. That may not be a rumor. That could be true. But at the same time, I really try my best to help you before the test occur. So I'll definitely try to give you some example questions, but they may not be as challenging as the actual test. So try to speak to me whenever you got stuck, maybe on certain aspect of the course as often as you can. Maybe that can definitely help. Yes.
So my other question is that, are you, I'm hoping that there's not going to be a 50% for the final exam, is there?
You know what? I heard about this kind of policy, 50% rule. What is that exactly?
It's that, so like, let's say, when everything's said and done, you've earned like 60% of like all the course, but you got less than 50% on the final exam, then you fail.
No matter what. Oh, I see what you mean. So even though your calculated roll mark is 67, for example, but since you failed the exam, you still failed the course? No 50% rule in this course, okay? And you can easily see that it's actually documented in the syllabus, but I'll write it down. No 50% rule, meaning that, let's say if you fail the exam, but your roll mark is still more than 50%, you still pass the course. Take my word for that, it's recorded, okay? On the other hand, if you fail your exam, it's quite likely you will fail the course too. I would say quite likely, but I'm not gonna say for sure, but if you really do pretty well, maybe before the exam, but it's just that maybe you were not in your best condition to really do so well in the exam, of course, you can still pass the course, no problem, okay? No 50% rule. Okay, what about the workload? Yes, please. Of course. Okay, good question. The question was, what's going to be the format for the exam? Okay, let me write it down. It's going to be completely in person, number one, and in person. And the date is going to be scheduled by the registrar office. So make sure you don't make any travel plan in the exam period. In person, and then it will be a paper test. So there will be no programming components. We already kind of assess your programming ability in the 2 programming tests. So for the exam, you can think about it's more about, but although you might write some code on the paper, you may have to. You may have to justify certain properties of a data structure. You may have to recall some definition, or you may even have to write some code on the paper. That's also possible. But do you have to use Eclipse? No, you don't need to. Okay. Yes, please. Very good question. The question was, how much time will you be given for doing the test? Let me say tentatively, okay? But the bottom line, however much time you might be given, I'll make sure the material given to you to solve during the test will be appropriate. But for now, for both of them, okay, given the confirmation I got from our computing manager, so Wulia told me that we can reserve the Williams Small Center for about 15 minutes to 1 hour during the class time on Wednesday. So I would say for both your programming test and written test, it will be up to 15 minutes. However, for the written test, I can tell typically it should be about 30 minutes. I will try to confirm a little bit, maybe a little bit later. But for your programming test, it might just be about 15 minutes or to 1 hour. It's only tentative. I will try to see if I can coordinate, I can maybe negotiate with the instructor who actually follow our session to see if they can maybe let us stay maybe a little bit longer. But don't panic. However much time you're given, I'll make sure that you will only be given reasonable amount of problem to solve. Okay. Yes? Yes. So for the exam over here, let's say in case you're asked to write some code, will you be required to write invalid Java syntax or just pseudocode? I would say it kind of depends. If the question say, write invalid Java syntax for this method, of course, no way around. However, if you're asked to write Java syntax for the problem, for issues like a parenthesis or maybe semicolon, that wouldn't change the meaning of the program, we are tolerant. We wouldn't deduce any marks. We'll focus more on the meaning, okay? And yeah, that's pretty much what you asked, right? So, and of course, for the programming test, you have to make sure it's strictly Java, right? At this level, if your program that's submitted at the end of the 50th or maybe 60 minutes cannot even compile, it's not very promising. I'll talk about how we're going to evaluate your programming test a little bit later, okay? Any question? Okay, sounds good. Okay, what about the expected weekly workload? This is only like a standard, right? This is actually somehow formulated by Lasson. Let me just mention very quickly. For every credits, you should be working for about 3 to 4.5 hours for everything, okay? So since we got 3 credits for this course, so it should be between 9 and 13.5. If you're able to do so well without spending even 9 hours, good for you. I have no trouble with it. If you are falling within this range, I would say that's reasonable. If you find yourself having to spend so much beyond 13.5 hours, I would suggest maybe speak to me right away to see maybe the way you study was not the most efficient way, the most productive way. Number 2, you shouldn't really feel so bad because this course here is a very foundational one. So it might just challenge you at the moment. Without having dedicated the hours, you wouldn't grow intellectually, right? So that's only an estimate, right? So that will include all the lectures and also office hour or any, when I say problem-solving sessions, I'm mainly talking about after your assignment deadline has passed, I may just schedule some extra session, maybe to go over the solution with you. So if you want to attend, that can also be included, right? We'll see. And also there will be, of course, you got to spend some time struggling through the assignments yourself and discuss with your friends, that's okay. And also you want to study for the lecture and the test or for the exam, right? Roughly speaking, right? It's a foundational course. Don't feel too bad if you have to spend so much time on this course. And the next one will be about how we can figure out the letter grade. So here, actually, this here also implies there's no 50% rule. All we're going to do is to calculate the weighted sum. And then if you click on, this is a link. If you click on the link over here, it tells you how we map your row marks into letter grade. For example, the cutoff for A+ will be 90. The cutoff for A will be 80, and etc. Just standard. No trick over here. Okay? Okay, so here is just an example about how to calculate the row marks and also letter grade, right? I'll let you study the math if you don't feel comfortable, okay? All right, about attendance, okay? It's optional, okay? You wouldn't get any punishment in terms of the mark if you don't show up in the class. However, I do want to encourage you and reward you if you come to my class and maybe contribute, by discussion or simply just by paying attention to what I have to say about the course. Right? You can definitely read it. I just lay out the scheme very precisely over here. At the end of the semester, you can assume I'm going to follow this scheme faithfully. Okay, no trick over here. If I promise, I'll definitely give it to you if you come to enough number of classes. But what should you do from your end? If you already took a course with me, maybe in 2030, last term, you should have already set up this app. It's called iClicker on your mobile device. If you haven't, please try to set it up by Wednesday's class. On Wednesday, let's do some trial attendance checking, just trying, okay? And then maybe starting from next Monday or even next Wednesday, we can start making it more official and start giving you some credits, okay? So what should you do? Once you get to the syllabus, please refer to this guy over here, and then you will see different section over there. Please make sure you do not go through the instruction for using eClass integration. We don't really use the eClass for iClicker. It's a standalone app, okay? And I'll just highlight what you really want to pay attention to. You have to make sure, make sure you supply this valid student number, because I'm going to use a script to process your attendance record, like a spreadsheet. If you supply the wrong student number, then you wouldn't get your credits. So please make sure you double check the student number you put in, and also your my.yorku.ca email. Please make sure, okay? Otherwise, it should be very straightforward. And once you have installed the app, we're gonna try that together on Wednesday. Every time when I launch the iClicker on my computer, I'm going to start some random poll. And then you will definitely see that on your mobile device. And then make sure, if you ever got this prompt, you want to make sure you allowed location service, because that one there will require you to be here physically in order to take attendance. I don't want to make it unfair for you, because your classmate may just stay home and take attendance from home. That's not fair to you, all right? So guys, any question about this? Don't worry, all the information is on the syllabus, right? Everything's transparent, right? Nothing's hidden, okay? Yes, please. Okay, very good. So usually when I present a question on the screen for you to take attendance, don't worry, there's no way you can get it wrong. You'll see what I mean on Wednesday. Okay, but answering the question is not the point. As long as you're here, checking in, and then you'll be fine. Oh, when would I start taking attendance? It can be any time, 5 minutes after the class starts, for example, like 10:05, or any time about 5 minutes before the class ends, about 11:25 or 11:15-ish. Every time I take attendance, I'm only going to do that for about 2 or 3 minutes, and we can let you guys take some break at the same time. Once I end the poll and no complaints about any technical issue, if you come to me afterwards to say, oh, I was there, no. All right, because every time I say, is everybody okay with the attendance? If you got any question or problems, you should raise your hand right away. So we may just be able to resolve that for you, okay? Hopefully you guys will be fine. It should be very straightforward to do, all right? But guys, don't really stress over too much on this. You can, if you see the scheme more carefully, it's okay to miss maybe 1 or 2 classes, but you can still get a 5% bonus. I'll give you up to 5%. It's more like a letter grade, just to show my appreciation about coming to the class and getting engaged in the course, right? Okay, any question about this? Good. All right, about the semester calendar. Let's take a look. Okay. Let me see. Okay, so as I mentioned before, that your test, written test and programming test, they will take place on the Wednesday class time, starting from 10 a.m. Okay, I will definitely give you more precise instruction about 1 week before the first test, so don't worry. I just want to give you some principle about what to expect. And then for your assignments, all the written tests and programming tests are fixed, unless extreme weather, in which case we may have to postpone. We're going to cancel the class anyway, right? We're going to postpone maybe to the next week or later. And it happened once. There was a fire alarm triggered by some system malfunction during the test, in which case we also need to postpone. But it doesn't happen often, all right? So anyway, you don't need to worry. So the announced dates for your tests, you can assume is set in the rock, okay? And what about assignments? So if you look, I'll explain the assignment due dates in a moment. So let me just go to the calendar. So this is a better one. Oh, where can you see that? For your convenience, you can also go back to the study the lecture site. Oh, sorry. If you see here, semester calendar. That's the one I'm going to go over. Okay? If at any time there's any updates, I'll let you know. Otherwise, this will be pretty much fixed. Okay, let's take a look. Let's start with the lecture. We are here today at lecture 1, 2, all the way to 24. That makes sense, right? So April 5th will be our final lecture date, the final class. And then let's start with the written test. You can see I put the written test number 1 over here on the 8th of February. So it's a Wednesday, which means on the Wednesday during the class time, you want to show up, not here, but to the Williams Small Center. I'll confirm with you about it very precisely before the test. And okay, so what about the coverage for the test? So you can see here, written test 1 over here, I will not cover lecture 9. That might be too rushed. You have to study up to lecture 8. 1, 2, 3, 4, 5, 6, 7, 8 for written test 1. Makes sense, right? What about written test number 2? Written test number 2, I'm not going to cover this. So I'm going to cover 9, 10, 11, 12, 13, 14, 15, 16. All right? Also makes sense. And what about the assignments? So assignment number 1 is going to be about recursion. The reason that I want to postpone the release date until week number 3, for 2 reasons. I'll put it here. So for these 2, for the beginning 2 weeks, let me make it a little bit thicker. For week number 1 and week number 2, before assignment 1 is released, you want to maybe catch up or brush up, with recursion basics. Because we simply just cannot teach you recursion from scratch, I'll try to do a little bit of highlights about what you should really watch out for the recursion. And we'll do some simple example together. And for assignment number 1, I'll give you some challenging problem to solve. And of course, based on our policy, you don't need to worry about losing any marks on the assignment. But in order for you to do well in the subsequent programming test, you have to make sure you really struggle through the assignments, ask for help, either from your classmate, from myself, or from the TA. Anyway, you got to make sure you learn the material. That's what I care. Okay? So you want to catch up with the recursion basics, and also there will be some basic problem I'm going to assign to you as well. You also can take advantage of the first 2 weeks to catch up with recursion before I give you the assignment for 2 weeks. All right? Assignment number 1. Okay? Assignment number 1 will be for 2 weeks, and then I will give you assignment number 2 as well over here. And I don't really put any precise release date for the assignment, but typically they should be released on Monday. Okay? But I'll try to give you 2 weeks if I can, but sometimes the extent for the assignment wouldn't require 2 weeks, maybe just 10 days. But I'll try to give you as much time as possible. Okay? It will be reasonable. Okay? Nothing for you for the reading week. Okay? And then assignment number 3 and 4. Oh, sorry, let me say one more thing. After completing assignment 1 and 2, you definitely got a reading week to maybe review what you have learned programming-wise from assignment 1 and 2. And after the reading week, we got your programming test 1. Okay? So programming test 1 is actually going to cover 1 and 2. I can already tell you what it's going to cover tentatively. Recursion, which will be assignment number 1. Number 2, linked list, which is about assignment number 2, 1 and 2. Okay? And the next 2 assignments over here, 3 and 4, will be about the tree data structure, which is very, very common in a standard programming interview. So that's why I want you guys to make sure you get some experience about programming in the formats and under the kind of time stress if you go for some programming interview. Okay? 3 and 4, so it will be about trees. And definitely implies, if you say you want to program a method on trees, it's almost impossible for you not to have recursion. Okay? So it will definitely imply you have to know recursion pretty well. And programming test number 2 will be on March 29th. So that'll be the second programming test, which will test you on these 2, trees and recursion. Okay, I think that's about everything I want to cover. Do you guys have any question? Oh, actually, one more thing to mention here. Drop deadline is on March 17th over here. So I can definitely, given that it's only multiple choice question for written test 2, I can release the mark before the drop deadline for you, absolutely. And for programming test 1, I'll definitely try to make sure I return the marks back to you as well, in case you have to make some decision for yourself. All right? That's about the plan. I would say that's pretty much final. I'll do my best to really keep it consistent and in time. And you guys do your part. All right? Yes? You mean the office hour? It's 3:30 to 4:30 on Tuesday, Wednesday, Thursday. Yeah, but that's okay. I'm glad you bring it up. Could be the confusion for others. Let me show you right away. By the way, guys, for the syllabus, there are hyperlinks on the first page. So you can definitely click on the section if you want to. So just easier for you to navigate. For the office hour, yeah, there we go. 3:30 to 4:30, Tuesday, Wednesday, Thursday. Okay? You can either see me in person or Zoom, either way. Okay? Alrighty. Okay, so we have covered the semester calendar as well. The final bit, we're pretty much done. So coverage of the test, right? That's something I just explained. Let's keep them also tentative. Sometimes I may just want to reduce maybe one lecture, and sometimes I may just want to add 1 or 2 lectures from before. I'll let you know precisely what you have to study for, at least 1 week beforehand. Okay? And about a weekly schedule just for this course. Of course, you're going to come to the class, ask questions, listen to my lecture, and then see your classmate, right? And office hour over here. And I'm going to make the email of the TA available to you as well. So you can also schedule some problem-solving session with them if you want to. All right? That's what we plan for now. And about the lecture topics. So rather than having like weekly breakdown, I think we'll try to go maybe with maybe with the dynamics of you guys. If you understand very good, very well, I can cover a little bit faster. Otherwise, I go a little bit more slowly. We'll see. But that's really what I plan to cover in this course based on what I did last year this time. But that one was more like online delivery. So in-person delivery could be a little bit slower. I don't know. We'll see. Okay. I can tell you right away, hopefully that wouldn't disappoint you too much. There'll be 2 topics which I don't think we will be able to cover in this course. I can tell you right away. One is about the graph, which I mentioned, but for that one there, you don't need to worry. You're going to learn that in 3101, the algorithm course. The second one is hash table. That one there, however, hash tables are actually quite a straightforward topic to actually follow through. If you're interested, of course, hash table will not be covered in your exam if you don't cover that in the lecture. But if you're interested, let me know. I can share some slides with you if you want to study that. Reach out to me, maybe at the end of the term. Okay. All right, guys, any question?
If it's straightforward, why aren't we would it be too much?
Oh, you mean the hash table? Yeah. When I say, well, of course, sometimes when I say straightforward, I'm exaggerating a little bit. Even though it's straightforward, but we still need 1 class or 2 to really cover some basic principles, which are not really complicated. And also, we need to cover some examples to make sure you really get it. But maybe I would like to rather use those 2 classes maybe for the more advanced topic over here about heap sort and priority queue. I will see what I can do. If we can really, I can even just make the slides available to you at the end of the course and then highlight certain things you can watch out for. That's what I can do too. Okay. All right, guys, that's about the course syllabus. Any question? All right, good. What I will do is let's finish just one more bit. If you need any accommodation, please let me know. Okay. And let me see. Why don't we take a 3 minutes break? Okay. It's now, according to my watch, 10:52. Don't go too far. Let's take a 3 minutes break. We'll come back 10:55, and then we'll do some introduction to the course. All right. Stretch out your legs, walk around if you want to, 3 minutes. Don't go too far. Yes. Go ahead.
No, for any music there is no kind of accommodation that's perfectly fine. But so I live like an hour and a half away driving wise. So I'm gonna be honest with you. Monday I only have this class, and so I've taken your class before. And I know that it's recorded lectures. So my plan was to watch the recordings. To be honest, is there any like bonus assignments? It's fun there. We're supposed to be coming in person. So
Yeah, I know what you mean. I may have to say no for now, because as you say, it's in person, so we don't have that many. Yeah, so it'll be understandable if you really cannot make it to here. But as I said,
I'm coming Wednesdays because I have other classes.
okay, no worries.
I just,
Yeah, in the worst case, if you count to 50% or can be more of the class, you can still get about 1.5% bonus. Yeah, yeah.
Okay,
No problem. Guys, 2 minutes. Okay, 1 more minute, and then we'll resume. Just get yourself ready. Okay, a brief moment, and then we'll start. Okay. All right, let's resume. Okay. Okay, so let me give you some brief introduction and some motivating problems about why this course could be useful. Let's take a look, and then we're gonna hopefully I can start the tiny bits of the first lecture, which will be some review on the recursion. Okay, if I cannot finish today, definitely Wednesday. Okay. Okay, so one useful mindset about this course is it's more like a programming interview training course. So one of my senior colleagues, he liked to put this course as the interview course. So maybe you guys are planning maybe for some interview for your co-op or maybe some part-time job, maybe throughout the semester. I think what you learn in this course, especially about linked lists, arrays, and also trees, they will be very useful. Anyway, so that might give you some motivation. It's really good for your future career. And real software developer, they really go for some precise specification. And one way to do it is they might be given some API. API is simply just a method declaration. So should it be an accessor, which returns some value? Or should it be a mutator, which returns void? And what kind of parameters or input should the method take? And once you get the body of the method, what should it exactly return? Right? So these are the various issues you have to consider when you program a method. And what we're going to do for this course is we're going to give you a set of JUnit test cases for you to get a feel about how the method is supposed to work. For your assignments and for your programming test, we'll give you some initial, okay, let me visualize for you. Okay, it's good to also have some communication about this little challenge for you as well, okay? Basically, for your assignments, and guys, by the way, sometimes I might be talking about on my iPad, but I forgot to switch. Please shout on me if I forgot, right? This time I remember, but sometimes I might forget. For your assignments and also for your programming test, you can think about what you will be given will be some, we call the starter projects in Eclipse. There will be various packages. Notably, there will be one package called tests. And there will be some, for example, tests.java. And this file over here gives you some initial. So this will be give you some initial idea about how methods should be, number one, declared. Should it be, as I said before, should it be an accessor or should it be a mutator? You got to decide. And what kind of parameter you will take. And we're going to talk about it also later. Should it be a generic parameter rather than just integer? Right? We'll talk about it later. And number two, should be implemented. Right? So these are the two things. You'll definitely have that experience and preparation in the 4 programming assignments for sure. So that'll be the tests, and then you will be given some model package. Basically, model is just a standard term to say all the useful logic should really go into this particular package. And it will be empty to begin with. What does that mean? That means you will be the person to make sure you create all the necessary classes and methods inside this empty package and make sure you get a green bar from the starter test. That's the first step, okay? I call this the starter in the sense that it only supplies some example scenario which cannot be complete. Potentially incomplete. And what that entails is you are expected to two things. Okay, so it's more like give you some general guidance about assignments and programming tests. Two things. Number one, do not hard code your method just for the given tests. Hopefully, most of you are have not been doing it. You pretty much know what I mean. For example, if the input I give to you is to say, for example, 2 plus 2 is equal to 4. So in your method, you say, if input 1 is 2, if input 2 is 2, I'll return 4, right? That's extreme, but hopefully you're not doing anything like that. Your method should be general enough to really handle all the possible scenarios for the input. Okay, so you definitely don't want to hard code. And number two, you want to write additional JUnit test cases. To cover the missing scenario. Okay, are we clear so far? And the consequence of what I have said so far is when we evaluate your, for assignments, I will always give you the extra tests after the submission deadline. But for your programming test, here is the consequence. When grading your programming test submissions, several things we'll check. Number one, the minimum compilation. For example, if in the JUnit test that we give to you, the method is supposed to return integer, but somehow your method returned a string, right? You wouldn't compile, obviously. Okay? You would definitely get some penalty for that. We'll talk about how much exactly the penalty will be. But at this point, it really shouldn't have compilation error. Number 2, passing the starter tests, which you know precisely from here. Number 3, which I'm going to use a different color. Number 3, additional grading tests. So these tests may simply use different input value to make sure you didn't hard code your method. Or it simply will try to test your method on certain scenarios which can be easily derived from the problem description. But they were not really covering the starter test, right? That's also part of the evaluation. I know students usually don't like this part. But I think that can somehow force you to be more responsible for your code, to make sure what you really see during the test is not all you're going to be evaluated by. You definitely want to make sure you take more responsibility for the quality of your code. Okay? That's more like a conceptual clarification about your assignments and programming tests. Okay? But we'll talk more as we go through other materials. Okay, and then thinking abstractly. So you don't necessarily have to think in terms of the code always. But for this course, I will try to do many example walkthrough with you. And sometimes I will try to maybe explain in a more intuitive term. That means I'm being more abstract. But anyway, so that's something you want to keep in mind. Yes, please. Good question. The question was, if you do decide to write some additional test cases for your assignment and programming test, number 1, good for you. I'm glad you tried. Number 2, it will be up to you. You can submit them as long as they don't cause any compilation error to your submitted project, you're fine. Yeah. You don't need to delete them. It's good to keep them. Yeah. Okay, good. All right, and I included some website over here for you guys to look into. Maybe the next one. Okay, maybe a little bit later. But you can look at how they do programming interview at Google. Funny enough, they didn't, for this particular one, they didn't ask them to really sit in front of a computer and do programs in Eclipse. Instead, they ask you to go to a chalkboard or whiteboard. They tell you what the problem is. You're going to program on the whiteboard. And don't think that's actually easier than programming on the IDE. Because in order for you to write something that makes sense on the whiteboard without the help of an IDE, for example, without making any compilation error, is quite a challenge. That's something I try to do on the iPad sometimes. So I would say for you guys to really get used to this kind of mindset, you definitely want to practice. All right, question? You're right. They definitely want to see how you think. But when they actually see what you write on the board, right? Unless you say, I want to write pseudocode. Well, they might say you have a choice. You can write in your favorite programming language. It can be Python, can be Java, can be C. But let's say if I choose Java, whatever Java I write on the whiteboard cannot be too ridiculous, right? Maybe missing some semicolons is okay. But when I try to, for example, I try to take the modulo of a string, that totally doesn't make sense. So they will actually see from how you actually organize your thoughts on the paper or the whiteboard. They can already kind of extrapolate how things will work if you're in front of the computer. So that's what I meant. Yeah. Good. I'm glad you asked. Okay. Yeah, so I'll also try to assign it to you guys, maybe some extra problems in class. Take advantage of them as well. Try to do them on a piece of paper or on the IDE, try them out, and then come to me if you want me to. If I don't really give you the solution right away, you can come to my office hour, show me your solution, and then we'll go over. Okay? Okay, study tips. And yeah, so I record the lecture, but try to not make it as an excuse not to come to class. They're different, okay? And try to understand as much as you can without worrying about you might miss some notes or some verbal remark. Everything's recorded. and ask questions, which you guys really have been doing very well. And take notes if you want to, but I will also make my iPad notes available to you if you can just bear with my handwriting. And want to reiterate whenever you need it, all the recording will be there. Okay? It's not going to be taken down after the semester. General tips, yeah, to do well, yeah, hard work is really important, but it wouldn't just guarantee good performance. So I think, guys, that's the really disappointing part. Also, it's true. So you definitely have to do the hard work to really manage all the ground stuff, meaning that at least make sure you understand everything we talk about in the class, but you may have to go a little bit more beyond the class yourself. For example, you can go to the reference textbook and try the problem set yourself. Or you can try to maybe Google for some interview problems. Or I also got some links for you over here. There's one called Coding Bet. I think for those of you who actually want to catch up more on the basics of the recursion, you can definitely go to the Coding Bet. I'll show you what I meant. If you go to their website there, don't worry about the warm-up and string. That'll be insulting to you. Don't try. Okay? Go to the recursion over here. Recursion 1 is the basic one. You can definitely give it a try. And also recursion number 2. Those are the more challenging ones. So some of the assignment questions are based on them. So I'm thinking if you try both, that'll be good. And idea would be if you try in any one of them, for example, if I try this one here, you see, that's pretty much the format it will be given for the actual programming test or assignment. You may have to even declare this yourself, right? But anyway, let's say you declare that yourself already. You are given some example starter test. Let's say you program something here. Sorry, some junk. And I will say go. And of course, they're going to give you some error. Let's say, let me just do a little bit different. Return to hard coding. Okay? Go. Right? You can see are the evaluation tests over here just those that was given to you when you first were given the problem? Not really. They give you many extra ones to see how well you have really programmed your method. That's exactly what I'm doing for the assignments and the programming test. In the initial release for the assignment and also programming test, you will be given just some small number of starter tests. But when we evaluate, we're going to give you many more to see to see the quality of your test, your submitted code. All right? Good. Okay, let me go back. And also, you can look at the lead code. I think the lead code might be more applicable to you guys. I think that one is just a very standard interview preparation site. You don't necessarily have to subscribe to it by paying, but I think they do have some free resources over there for you to try, especially problems on linked list or problems on trees. That's something we'll definitely do in the class. Okay? And be curious about why things work the way they do and also the way they don't do. Like why they wouldn't work. So every time if I try to explain some problem to you, I also try to give you some alternative solution that may not work. You also need to understand why they wouldn't work. Okay. Okay. That's about some general tips. What's this course about? I will try to go for another 10 minutes or so, and then we'll start a recursion on Wednesday. Okay? But I might just point some resources to you at the end. Okay? But let's now do it very quickly. So this course is really about data structure. So what's really a data structure? That's something you will see. It's a very simple definition. It's a very specific and systematic way to organize and access your data. You can think about if I want to declare or define a particular data structure, let's say a tree, I need to know what attributes do I need and what accesses do I need to return some information and what mutator methods do I need to modify some attribute values, right? Those kind of the data structure. Okay? And so these are the data structure we're going to cover except for the maps and also graph. Otherwise, we're going to cover very substantially about linked list. It's quite a lot to talk about for linked list, and many questions that can go from there, and also the trees. And algorithm, we wouldn't emphasize so much about the algorithm in the sense that you will be given some algorithm right away to actually see how they work. But in 3101, the sequel to this course, you will be given the opportunity to come up with new algorithm yourself. That's the exercise you will do, one step at a time. But in order for your algorithm to work, there's going to be some underlying data structure you have to assume in order for that to work. For example, if I say I want to find out the maximum in some collection. That's an algorithm. But what will be the underlying data structure? It could be a linear array, or it could be a tree, or it can be a linked list, right? That's why the data structure and algorithm, they work together very closely. Now we're going to talk about inserting, deleting, sorting, searching. Well, I do have a searching problem for you to think about. Okay, analysis, specifically we're going to focus more on the efficiency of the algorithms. So you guys learned about the big O notation in the math course, I'm pretty sure. So we're going to brush up your memory about it by reviewing some basic definition, and we're going to apply the big O concept into coding. That's something we're going to know very well. In this course, let's say somebody give you some algorithm, or you come up with some algorithm, some simple one. What will be the time efficiency for that in terms of the big O? We'll talk about it. Okay? I do have some motivating problems for you guys. Just before that, I want to make sure you don't really miss the chance to do some background study yourself. I'm going to continue with this motivating problem in just a few moments. I already made this recursion part 1 available to you. So for those of you who really want to catch up with the basics for the recursion in the coming 2 weeks, you only need to spend about 3 extra hours, okay, to do this. Optional, but if you feel the need. So this is something I will talk more in detail on Wednesday. But you can just go to this site over here, 2030, and then go to week 12, lecture 8. I'll go there. I'll show to you. Okay, so that's the 2030 from fall 2021. Okay, if you scroll down all the way to the final week, so this is where I talk about recursion, the basics. It's about 3 hours of video, but plenty of time if you want to catch up the basics, because later on I'm going to assume you know about the basics. Okay, on Wednesday I'm going to talk just parts of them, just to highlight and do some recursion example together with you, and then I'll leave you to the programming assignment number 1. So for those of you who really want to do some work right away, I encourage you to go to this site and then follow through the lecture video to make sure you're okay. Okay? That's about what I want you to do about recursion. But let me go back to the motivating problem. The first one. So here is a problem for you guys, and then I'll give you some code to consider. Let's say the problem we have is we want to save maybe the health records of a mega city with maybe 10 million residents. 10 million is what? 10 to the power of 7, right? How do we do that? So let's say this is some use case scenario. Given a particular resident's social insurance number, SIM card, how fast can you locate their record? Okay? Think about this problem just for a little moment before I show you some code, and then we'll do some little bit discussion on that. Okay? Based on your knowledge from 2030, how would you implement it? Yeah, so if you say HashMat, since we wouldn't cover in this course, but for those of you who may be interested, one way to do it is definitely to use a hash table. I tell you what the problem is. Because for the hash table, you have to watch out for collision for your keys. If you got severe collision on your hash code, then it might still end up in linear time, which will still be 10 million, just for your knowledge. That's good. Thank you. Go ahead. Yes, absolutely. So yeah, that's kind of the implicit assumption. The SIM card, or whenever you want to do some search or look up, the information used to search up for should be unique, right?
And also, I guess for this problem, using a very large array would kind of be analogous to using your hash table and then you just index after the social insurance number. It's like over there, and you just get that.
Yeah, absolutely. I think let's not go too much into the hash table since we wouldn't talk about it in this course, but let's talk about array, what you just mentioned, which would be a very nice transition to some example solution. Okay? But I'm going to go over line by line with you, and we're going to have some discussion. I'll make it larger. Okay, let's go over. So let's say we want to implement this find method. This will be your SIM card, integer. And we want to return some resident record or health record objects. And all we do is, very intuitively, some for loop. Okay? So we're going to go from the beginning until the end, right? Remember the length of the array, right? We're using the primitive array. And then incrementing the loop counter. And we are trying to make it as efficient as possible. We say that if the current record that we are looking at index I, its SYN card, its SYN number, is already equal to the one we are looking for, then there's no need to really go any further. In which case, we just return the record. Everybody okay with the logic over here? Pretty straightforward, right? Okay, good. And is this the best solution for us? No, okay, otherwise I would have asked you, right? It's not. Okay, but in this course, we ought to know how to criticize on that in a very educated way. Okay, but let me help you with a little bit. The actual solution, you wouldn't learn about it until after the reading week. Sorry about that, just please wait, but I just want to get you motivated. Okay, so let's talk about this. Let's say we have some database over here, which is a primitive array. And we say a mega CD from 10 million, right? Index 0 all the way to 10 to the power of 7 minus 1, right? That's the largest index, okay? Whenever you want to have some analysis on the efficiency of your algorithm, which we will formulate later when we talk about Bay-O, let's do a little bit more intuitively. Think about in terms of the number of iterations before you can really return. What would be the best case? What would be the worst case? Yeah, absolutely. The best case would be, if this is the one we want to find, that's it. Only one iteration. But you're not guaranteed the best case always, are you? What about worst case? Over here. Yeah, absolutely. 10 million. Okay? This one over here will be the best case. Just one iteration. This part over here, if the SYN card you're looking for, or it simply doesn't exist, in which case you cannot really conclude it doesn't exist until you have scanned through all the entire array. This will be the worst case. This will be exactly corresponding to the number of residents, so 10 million. Okay, just give you a little bit more notes. This will be the number of residents. And if you think about the number of residents over here, if you make it n, which is a very typical way to really make it more formal. Let's say n. In that way, we know that the worst case, depending on how large n is, the most number of iterations you have to go through before you can find the result is corresponding to n. All right? Can we do better? When n is very large, like a 10 million, it's not so efficient, but we can do much better. Okay? And what I'm going to mention in the following is going to be something you will learn. Okay? I'll write down the name and then give you some intuition quickly. Okay? Well, so this is not very efficient. An efficient solution is to have the so-called, okay, let me be very careful about the phrasing, a balanced binary search tree. So guys, look at this phrase over here. It tells many things. It will take us maybe at least 4 to 5 lectures to understand completely what this really is. But that's okay. Let me just give you some intuition. A tree is basically something like this. Start with something here. It might just go to maybe have some branching structure and etc. Oh, we're actually reaching the end, right? Okay, I didn't really watch out the time. How about this? I will continue with this balanced binary search tree solution over here to make a conclusion. I got 2 more motivating problems for you, and then we'll go to recursion. Bear with me 10 seconds. I do apologize for not ending in time. For those of you who really want to catch up with the recursion, please look at this slide first. If you really want to catch up, now would be the time to start. Don't wait for me until Wednesday. Wednesday, we're going to go quite quickly on the recursion. Any question, I'll take first. Go ahead. Mm-hmm.
If it's made so that it's in order social insurance number, and you know that like when it starts from, let's say it starts from like the number
Yep.
2 million,
Yeah.
and then each element, like each member of that array, just like the social insurance number is one later.
Yeah.
Would it just be a matter of the next if you're just
Yep. Yep. How about this? If you don't mind, I think it's a very good insight. Mention that one more time when I start a lecture on Wednesday. That's something about sorting, which will also take some cost as we go. Yeah. Guys, thank you so much. I'll see you on Wednesday. And make sure you install iClicker. We'll take some trial attendance.